welcome and good morning. Welcome to the Pearcey Foundation's Australia 4.0 discussion series. And I'd like to start with a brief acknowledgement of country, which I want to acknowledge that the Pearcey Foundation acknowledges the traditional custodians of the lands on which each and every one of us is sitting. And we invite everybody to recognise the contributions that the Aboriginal and Torres Strait Islander people have made, and our respect for their elders, past and present, and the traditions and living cultures in this country that are of the original occupants, who are a valuable resource, as are those of all who've come to make Australia their home. Together, we are Australia. A brief bit of agenda for everyone. First, I'll just make some opening remarks, and then we're going to move through to hearing from our panelists, and then we're going to open the floor to Q&A. So I invite you all to listen and to think carefully, and we look forward to having a dynamic discussion. When you are ready to ask a question, it's probably going to work best if you can use the Zoom function to put up your hand, or if you want, you can type it into the chat box and I will try and get those questions asked. So Australia 4.0 is an initiative by the Pearcey Foundation to recognise that the moving towards a net zero Australia, the transition of our electricity environment to a decarbonised environment, presents an enormous number of challenges. And with each of those challenges come some significant opportunities. And in our particular lens, we're looking at where this transition of the electricity system intersects with the ICT sector. So the industry sector and the ICT sector coming together to meet the challenges and to benefit from the opportunities. So it's a series of 6 discussions. Today is the first. And we look forward to having all of these produce some productive insights to benefit the whole of the community. And then we'll be having a half-day summit at the end, bring everyone together and see if we can't consolidate those insights and learnings and continue to move forward as a nation. So with that said, I'd like to introduce as our first speaker, Professor Michael Brear, the Director of the Melbourne Energy Institute at the University of Melbourne. We have provided full bios for people in the initial information, and they're all available on the website. So I won't be reading those out today. We'll just move forward with each speaker. So that said, Michael, I'd invite you to share your presentation and start.
You should be able to see my screen and hear me, Jordan. Is that correct? Yep,
that's right.
Jolly good. Well, good morning, everybody, and thank you very much to the Pearcey Foundation for this opportunity to chat to you today, and it's a pleasure to chat to all of you. I'm going to give a quick summary of a project that myself at the University of Melbourne and some very good collaborators at the University of Queensland, Princeton University, and the NOUS group have been working on for a couple of years now. This is actually a very condensed summary of work that we presented in mid-April, our modelling results. And if you're interested in this work, I hope you are, we also have another report being released next Wednesday evening, which I can share the invite with you later on today. And it's the Net Zero Australia project. The Net Zero Australia project is basically looking at the scale of the decarbonisation problem for Australia, and also both for our domestic economy and for our exports. And if you look at our greenhouse gas emissions domestically and for our exports, you see some pretty stark things. So when we started this project, formally started in May 2021, 2021 and 2020 are looking increasingly far away now. Australia's economy was roughly a 600 million tonne of CO2 equivalent, CO2 equivalent being not just CO2, but the other greenhouse gases weighted by their global warming potential. We're about a 600 million tonne economy in terms of emissions. So if we're trying to decarbonise that by mid-century, it could be 2040 or 2050. We could take any trajectory we want. Being engineers, we took a straight line, but that could be any line you want. We have a certain task with a certain scale, and you can see that that involves getting rid of emissions from energy, but a lot of other things as well. But then when you look at the export problem, we have an abatement task. So this is stuff that we send offshore and which other people use to make things, electricity, iron, aluminium, so on and so forth. We have an abatement task that's roughly twice the size of the Australian domestic challenge. In terms of CO2, it's 1,200 million tonnes a year, and we need to decarbonise that. Or the world needs to decarbonise that. Let me be more precise. We don't actually account for those numbers in our national greenhouse accounts, but that's CO2 that ultimately comes from carbon from underneath Australia's soil, in Australian soils. And we also have associated with that about 15 exajoules of energy embodied in those exports, as you can see, primarily coal. 1 exajoule is 10 to the 18 joules. Big numbers. So we're looking at how we would decarbonise those two. We impose emissions constraints that are slightly different on the domestic and export sector, because we assume that the export sector decarbonises at the same rate but starts 10 years later than the domestic challenge. And that's because our major export partners, India, China, Japan, Korea, have slightly later targets. Now, there are many different ways that we can do this, and we can, on the demand side, on the left-hand side, we can have what we call rapid electrification or slower electrification. But there are many other permutations. So these are just some scenarios which are deliberately designed to be wide-ranging, rather than, certainly we don't intend any of these to be forecasts or illustrative of the future, but they're deliberately wide-ranging scenarios. So we have rapid electrification, for example, and that would be, for example, no ICE, internal combustion engine driven car on the road by 2050, which means, roughly speaking, no ICE car being sold in Australia in about 2035, because the average car on road is about 15 years. Similarly, we could have, everybody having heat pumps at home, everybody having induction cookers at home, so on and so forth. Or we could slow that down and we could do the similar kind of transition, but having it transitioning by the last quarter or so of the century, by which case there would be some EVs on our roads by mid-century, but not complete conversion to EVs. So they're the kinds of tunes you can play on the supply side, on the demand side. But in terms of supply side, we can look at plenty of different options as well. So one case is we assume, for example, the whole energy system by mid-century is completely renewable in terms of energy generation. So no fossil fuel use on anything by mid-century. We still have a CCS requirement there, which I'll talk about later on, and that's because we have carbon being emitted by non-electricity, non-energy sources. For example, cement making and chemical making and other such things that we still need carbon capture and storage on. So that would be one extreme. Another option would be to say, well, let's constrain renewable rollout. By constrain, in this case, we constrain it to be 5 to 10 times better than the best we've ever done in terms of annual capacity additions. The reason we do that is we then deliberately force very, very large, a heroically large amount of CCS into the system, just because our energy exports are so large and our energy consumption is so large, but particularly our exports. And then we have a sort of a bookend that opposes the RE plus scenario, we call it. So the RE minus still has an enormous amount of renewables in it, but also a heroic amount of CCS. And then another, we're not endorsing any of these options, by the way. They're just deliberately supposed to be opposites of, and therefore spanning the debate. We have another option, which is the onshoring option, where rather than sending that 15 exajoules of energy offshore, we instead keep it onshore to a greater degree and use it to reduce our iron ore to iron and our bauxite to aluminium in Australia. And it's quite an interesting result, as you'll see. In terms of specific results, there's a million different things I could talk about, and I literally could talk for hours on this stuff rather than 10 minutes. It rolls off the tongue what Australia needs to do to get to net zero. We need to deliver an energy transformation that's unprecedented in scale and pace. We need to transform our exports as an essential contribution to global decarbonisation, and we need to invest in our people and land, and you'll see why we need to invest in our people and land in a moment. Now, they all sound pretty nice and, as I said, slip off the tongue pretty easily. Transforming our exports, though, we have to remember that we put more carbon into the atmosphere via our exports, twice as much than we do domestically. So if we're really sincere about solving this problem globally, which where ultimately the global solution is the only solution that matters, the export problem needs to be solved. But if you look individually, and I won't read all these dot points through, you can see that start to get the sense of the scale of the challenge. I will mention briefly the growing renewables to our main domestic and export energy source. We're talking there about domestically 400 to 500 gigawatts of renewables by mid-century domestically. Forgetting about the export stuff, that's the domestic challenge. We have about 25 gigawatts today. Another interesting one is point 6, attract and invest $7 to $9 trillion of capital. That would pay for more than a few solar panels and more than a few lines of code written, Jordan, as well. And with that kind of investment, and a few data centers. So that these are enormous capital investments that need to happen. And finally, point 10, attract a skilled workforce that grows from about 100,000 today to 700 to 800,000 by mid-century. Give you some numbers to back these kinds of things. Here is plots of energy use in terms of, this is primary energy use for the domestic sector. Once again, I apologise for presenting in exajoules. It's not a unit that many people commonly talk about, but 1 exajoule, roughly speaking, Australia consumes about an exajoule of electricity, which is made from about 3 exajoules of coal and gas and renewables at the moment. So we're about a 6 exajoule economy right now, and you can see for all of the net zero scenarios, the reference scenario is the one where we forget about climate change, but you can see for all the net zero scenarios, what you see is a dramatic reduction in fossil fuel use and an enormous increase in renewables. Now, how you formulate the different scenarios, you get different amounts of renewables or not. And indeed, how you formulate scenarios depends whether or not you completely exit fossil fuels by mid-century or whether you have some continued fossil fuel use and carbon capture and storage and other things to achieve net zero emissions. But the 5 scenarios on the right-hand side are all net zero scenarios. And all of them feature, as you can see, several exajoules of renewables. How much of whichever type you get, well, that depends on how you make your input assumptions. But when you look at the export task, you get an even more sobering picture. So we're about a 1 exajoule electricity nation at the moment. So 2 to 3 exajoules of fossil fuels go into making that electricity. These are the kinds of numbers you get for exports. And you can see for the net zero scenarios, we're going up to a 30 exajoule or something export challenge. Now you will say, oh, hang on a second, our energy exports at the moment are 15, 16, 17 exajoules. That's indeed true, but this is the primary energy. So this is the energy that you would need to make in Australia to deliver 15 or 16 or 17 exajoules to Japan, Korea, and China. So when you're making renewable energy and you're converting it into hydrogen and then a hydrogen carrier such as ammonia or something else, and then reconverting it back at the international customer, there are energy losses that mean you need to make significantly more energy in Australia. And that's different to, for example, digging up a chunk of coal, putting it on a ship and sending it to Japan, where there's the actual transport process is more energy efficient, although the greenhouse gas emissions associated with that are enormous. Now, going to this capital investment task, and you see some quite stark numbers. This is the cumulative capital that would be expended over these periods for both the domestic and export sectors. You can see the $7 to $9 trillion number. Now, that's an enormous number. as a reference, for example, if we say there's 10 million dwellings in Australia, and let's just back of the envelope say that the average dwelling's worth $1 million, it's actually a little bit less than that. The entire Australian housing stock has a current value of order $10 trillion, so comparable to these investments. But if you think about that, and most of this investment is done to serve international customers. This is investment that would be given to us by international customers in the form of long-term contracts, as they currently do for LNG and coal, for example. And you can see that trillions, though, not just being an enormous solar investment and renewables investment, but also enormous investments in network services, both electricity and non-electricity. But still, these are very large numbers. To give you an idea of what the nation would look like in a net zero world that's servicing both our domestic and export sectors, is we can present lots and lots of maps, and here's just one. We can do millions of maps. You can see lots of interesting things. This is the case of, you see transcontinental transmission from north-south along the West Australia and eastern seaboard, from central Queensland down to Adelaide and down to Melbourne. You see offshore wind in the Bass Strait. You see wind and solar all around our major cities, but you see these enormous, effectively solar farms. There is wind co-located with them up along the Sun Belt, and that is generating green electricity to turn that into green hydrogen, to pipe that to the ports, to make it into ammonia, to send offshore. And so to give you a sense of the scale of these assets, there's about 20% of the land in those areas is covered with solar. So it doesn't look, it's not completely carpeted as this zoomed out view suggests, but each one of those assets is of order the size of Tasmania. That's the size of what an economy that would currently delivers 15 exajoules of energy internationally and consumes 6 exajoules domestically. This is what the nation would look like if we were to replace all that fossil fuel energy with renewables. Now, we can play lots of tunes on these maps. For example, if we make small changes to the capital costs and make other assumptions, you can move those investments all around the country quite easily. In other cases, we move them to South Australia and Western New South Wales and Southern Queensland. So these are just indicative. These are certainly not meant to be in any way explanatory of the future. In terms of job tasks, and I apologise for Acrobat doing some funny things to this figure on the x-axis, but you can see the kinds of number of workers we're talking about here. We're talking about going from about 100,000 people today to about 700 to 800,000 people by mid-century. And before we think that that is a task that is itself unachievable, I'll emphasise that right now we have about 2 million healthcare workers in Australia. We have more than 1 million or so people working in manufacturing, construction, and professional services. And I think we've employed more public servants in the last 20 years than we have in these projections from now to mid-century. Now, so as the population grows, I think that these kinds of transitions would make the energy sector a significant employer. It's currently not. It's only about 8 or 9% of the workforce. No, sorry, I lie. It's a couple of percent of the workforce. It would make it a significant employer, but certainly not a dominant employer. It would probably be somewhere between 3rd and 8th largest employer by sector. But think of those jobs. These are skilled jobs. 2/3 for TAFE grads and 1/3 for uni grads. These are skilled. I hope an easy sell to the Pearcey Foundation. Interesting jobs, high-paid jobs, and secure jobs. So these are, to compare this to working in the gig economy or whatever else, you'd have to think that these are pretty good jobs for young Australians over the next 30 years. So that's me done, Jordan. I'll put a link in the note for our event next week, but I also encourage everyone to have a look at that website, because everything I presented today and all our input assumptions and everything is all publicly available via that website.
Thank you very much, Michael. And I would certainly commend people to take a look at the reports from the Net Zero Initiative. They're very informative and they're very balanced, and I think they give you a good broad perspective of what's possible and what's required to make it possible. So now we're going to take a slightly different tack on things. I'm going to invite Dr. John Ward, who is the Research Director of Energy Systems at the CSIRO Energy Division, to share with us his perspective.
Thanks for that, Jordan. Hopefully you can see my screen. Is that shared correctly? Excellent. Okay, so thank you for the Pearcey Foundation for organising this set of talks, both today and the ongoing series. I will cover some of the same things that Michael just covered, because I think the framing of where we're up to and the challenge ahead is very important. But I am also going to delve a little bit more into the power systems transformation as a particular focus of what I'm talking about today. I'd like to start by acknowledging the traditional owners of the various countries that we're on today and their elders past and present. As an online event, I recognise that there's multiple different traditional owners and the lands that we're meeting on today, and I acknowledge all of those. Okay, so for a framing perspective of this discussion today on an ongoing basis, as Michael introduced, it's really helpful to have a look at the magnitude of the challenge that is in front of us. So this is National Greenhouse Inventory by sector. This is the reports that the federal government, the Q, put out on a annual-ish basis. What is interesting here are all of the things that Michael's already talked about, and the size of the emissions that we have as Australia, the magnitude of the reductions that we're talking about as Australia. So at the moment, we're sitting in that sort of 5.5, 6.5, so 550 megatons CO2 annually, thereabouts. Now, what's interesting here when we look at the transition that's ahead of us is not just the magnitude of that, and out to 2030, Australia's committed to getting this down by 43%. So that means to roughly 350 megatons of CO2 emissions. Of that, more than all of it basically has to be achieved through the energy sector. And if we have a look at the Australian emissions projections that the Q have put out, that's an interesting thing about it. It's not that the energy sector takes the bulk of it. It takes more than all of it, of that reduction out to 2030. What we also notice from the energy sector at the moment is that of all the progress that's been made over the last 10 or 20 years, the energy sector has essentially been a flat line in terms of the emissions. So what's actually happened is that the introduction of renewables has reduced emissions from what they would have been without their reduction, but it's actually really allowed an expansion of the sector without a similar expansion of that emissions attached to it. So the reductions that we're looking at now are actually structural changes and reducing a lot of things that have been continuing, and that energy balance has been met by new renewables, but the reductions have to be met by structural changes of the existing. So that's a challenge that really is hitting us now and has not been hitting nearly as much over the last 10 or 20 years. Other framing piece, Michael and myself clearly didn't coordinate this, but we've each got our own version of how we present it. So the total emissions for Australia, this comes out of the Australian Energy Statistics that once again the Q put out on an annual-ish basis. These are the most recent ones. Really important to this is the diversity of different areas that we use energy, but also the significance of the export industry that Australia has. So my focus is substantially on transforming the electricity system in Australia. A challenge in that transformation is that the decarbonisation of Australia's energy system is going to require substantial electrification of basically anything that we can possibly electrify. And out to 2050, that's probably a doubling of the native electricity demand in Australia. But if we have a look at that big chunk at the top of the screen, the exports, depending on which future scenario you look at for how Australia transitions to some version of a green export industry, hydrogen, ammonia, high voltage DC, whatever it is, we're looking at probably somewhere between 6 to 10 times the Australian domestic energy consumption to then be able to support the energy to produce those green energy exports. So we're looking for some version of how do we sustain a energy export industry for Australia that's transitioned to green energy, and that necessitates a absolutely massive increase in the domestic energy consumption within Australia to do that. And that's the transition that we're tackling. I'll now put my CSIRO hat on a little bit more and say that although my focus in the work that I do is very much the electricity sector, for CSIRO, of course, we look right across the landscape in Australia. And I just want to make the point that electricity is part of it, but finding pathways for decarbonising the various industrial sectors, commercial sectors, and how we actually bring the community along on that journey are all very, very important parts of that challenge. On the right-hand side of the screen are the two key areas that I think about in terms of the electricity transition. One is, how do we actually fundamentally change the way we operate our electricity system while ensuring that it stays reliable, secure, sustainable, all of those things, so Australia has the secure energy supply that we need to drive our industries and all of our society. So that's number one challenge that I think about. And that challenge is really the fundamental change in the way that we put energy into the system and coordinate energy through the system. So we started with a system that's evolved over the last 100 years that had a handful of very large scale synchronous generators, transmission, distribution, and that energy flow went through to the end users. We're now changing to a system that, instead of having a handful of slowish responding large-scale generators, we have over 2 million quite small-scale power electronics-driven inverter-based generators, and we're trying to coordinate these inverters that respond much faster, so probably 3 orders of magnitude faster, and we've got something like 6 orders of magnitude more of these generators than we previously had. So imagining that we're in the sort of 9 to 10 orders of magnitude of a complexity of the problem as we go from slower, small number of devices to millions of much faster responding devices spread throughout the system, the challenge is immense there. So that's number one challenge that I think about. The second challenge I think about is that for Australia's native electricity demand out to 2050, I said that that would of the order of double. So just for that, to move that energy through the system, we could potentially look at, well, let's just double everything, twice as much transmission, twice as much distribution, pull out the poles, put in bigger ones, all of those sorts of changes. Or we can look at how to do that in the most efficient way that we can. And the way to do that in the more efficient way is to look at the capacity of that infrastructure, have a much better insight into the operational state, the actual engineering capacity of that infrastructure, and shape our generation, our use, and have prudent deployment of energy storage so that we can get much better, closer to the engineering capacity of those systems. So that's how I would like to see that go. It doesn't mean that we're not going to have investment in that transmission and distribution to support these higher amounts, but the size of that investment is very much dictated by how well we can actually make that management of that generation, transmission, distribution, end use, and where we put storage. That's why this is actually a really interesting discussion for the Pearcey Foundation to be involved in as well, that as soon as I say, let's try and better coordinate all of these devices through the system, then that's immediately a massive challenge that we're embarking on how to actually have that widespread deployment of sensors that give us that insight into the operational state. What are the issues that we're dealing with? What's the simulation and modelling that we need to be able to support and understand where that future state is going. What are the communications networks to get that data flow where we need to be making decisions? What are the algorithms that we need to develop to support that decision making? How do we present that information to our system operators, our distribution companies? All of these challenges are substantially in the ICT space, and hence really pertinent for discussion today. Okay, with that said, I'll make a point and a call out to the GenCost report that CSIRO undertakes and puts out annually. I don't want to delve into very much about that, but I am sharing one slide of the report that will come out this year fairly shortly. And as in other years, we see that lowest cost energy for Australia continues to be from renewables at various levels of penetration. That's probably all I really want to say here. So the challenge that we're dealing is not that we need a cheaper way to generate energy. We need a better way to integrate that into the system so that we can support this much higher volumes of renewable energy and the intermittency and the power electronics issues and all of those things that come with it. Those are the challenges that I'm thinking about, not the aspect of, is that generation at the generator the cheapest and best form of energy? We know it's the cheapest form of energy, but it's not necessarily the easiest thing to integrate into our system. Okay, changing tack yet again. I wanted to spend a little bit of time talking about the Global Power System Transformation Initiative that CSIRO and AEMO jointly lead for Australia. It's a global initiative. The challenges that I'm talking about for Australia are not unique for Australia. These challenges are something that the whole world is embarking on simultaneously as global economies all need to go on this decarbonisation journey. The consequence of us all doing this simultaneously is that we don't have to actually solve all of these problems ourselves, and the problems that Australia is best positioned to solve, when we solve them, we need to be coordinating with all of our international counterparts to share what we've achieved, learn from what they've achieved, and this is one of the mechanisms for doing that in the power system. The GPST was set up by a number of founding system operators, so these are AEMO and their equivalents internationally that are all dealing with these challenges simultaneously, and partnered with CSIRO and other leading research organizations internationally so that we could bring together the system operators dealing with these challenges at a system level, researchers dealing with the research challenges of actually how to make this evolution, and then a whole ecosystem of additional partners, and I specifically call out our Australian partners here. And for the purposes of today, having just followed Michael's talk, would make a point that University of Melbourne has been a substantial contributor to the work that we've done in Australia. But it's also many other of the leading universities, consultancies, etc. in Australia. So we've really brought the whole Australian research ecosystem along on this journey of how to actually make these critical changes to Australia's power system to support that decarbonisation. What's been happening and what we've been doing there is that 2 years ago is when we sort of let the world know what we were doing in this space. And what we did was we released embarked on and released a set of research roadmaps where we identified key aspects of the challenges that the power system is dealing with, put out this roadmap. And since then, we've now been working on delivering the implementation of those roadmaps in collaboration with AEMO in Australia. The most up-to-date version of where we're up to on these, we'll release those reports in about 10 days. So if you have a look on our website, which is linked at the bottom of this slide, or Google CSIRO GPST or something like that, you'll find the roadmaps and the first year of work under those roadmaps. But in about 10 days, you'll get the next iteration of that coming out. So watch this space. The pathway that we've been on, roadmaps, delivering on those roadmaps, and right now we've just embarked on stage 3 of this journey for Australia. So we will see some additional progress over the next year, and this will continue. Ultimately, Australia is going to need to have a phenomenal transformation of that energy system. Our short-term target is 2025-ish, where we expect that the NEM will need to operate on 100% renewables for periods of time. That's the stuff that's already happening in South Australia, but for the whole NEM to do that for periods of time is the short-term challenge that we're tackling. For the 2030, we've got the decarbonisation challenge, and that will be much longer periods of time and more energy storage. And then out to the 2050, we really need to have that system fully decarbonised. Okay. GPST, Australian focus here. We coordinate globally, and the first 6 of these topics are topics that we explicitly collaborate with a number of international partners and system operators to deliver. So these are 9 topics that we look at within the Australian context. The 6 initial ones: inverter design, stability tools and methods, control room of the future, planning, restoration, and black start and services, are all common topics that the international community are very keen to work together, and we have been working together with them over the last several years. The last 3 of them are ones that we've done as effectively Australian specials because of some of the challenges that Australia is tackling ahead of a number of the international system operators that we're working with. So the uniqueness in Australia is really the amount of small-scale generation we have right at the bottom of our low-voltage distribution networks. So that's businesses, homes that have put rooftop solar on. That's effectively what it is. And that has given us a situation that's reasonably unique internationally at just how much generation we have at that low-voltage level in our networks. The consequence of that is that how we set up our system architecture for the coordination of our system operator, our AEMO, our DNSPs, ultimately retails with the relationship with the customers and how customers interact with this system is a system architecture problem. And the 2 aspects of distributed energy resources that we're looking at there both also tie into this very large amount of embedded solar that Australia has, and consequently the wider distributed energy resources challenge of how do we coordinate what the solar is doing with existing loads, so hot water, air conditioning, some of those more obvious things, but future loads, including things like electric vehicle charging, and obviously the existing rollout of batteries into consumers, businesses, and into the network. So that's a pretty quick run through. This is, we're 2 years in with our partnerships with the universities and things in Australia. The global initiative's been going a little bit longer than that. We're now well and truly on the implementation and piloting phase of this work, and longer term, as challenges and the evolution progresses, we'll continue to review and adjust. So that's it from me. I thought I'd finish going back to this slide because although I've just delved into the power systems work that I spent a lot of time thinking about, it's really important to reflect that it's actually a much wider energy systems challenge that we're dealing with here. I just wanted to not leave on a final slide that suggested that I was only just looking at a bit of power systems. So that's it from me. Thank you, and let's talk.
Thank you very much, John. And I think it's really important to note, as John pointed out, that one of the biggest challenges that comes with this transition is the massive increase in complexity. And with that massive increase in complexity, we need to find ways to deal with it, and it's not going to be just human hands. So it's a real challenge, but also full of real opportunity. So that said, I'd like to move on and introduce Professor Neil Horrocks. Neil is the Director of the Centre for Energy Data Innovation at the University of Queensland. Neil, over to you.
Thank you very much, Jordan, and thanks again to the Pearcey Foundation for stewarding this really important conversation, because I think there's a lot to be done here, and a special thank you to Wayne, who has been driving this agenda for quite some time. So we've talked about the decarbonisation challenge, and we've talked about the network challenge as we see it, and I just wanted to bring a different view to to this whole issue, and that's the customer-facing issues that faces as we move into the transition, because, you know, this is very much a complex, the energy system is very much a complex engine that's going to require a lot of optimization and a lot of management to get good outcomes for the customers. But at the same time, customers will want to use this system and add to this system in their own way. So it's important we also consider their impact on the system moving forward. Now, their impact on the system is going to be wide and varied, and you just can't reach all of that. So I just wanted to touch on 4 areas where I think customers are going to have a big impact on what's going on. And these are areas where the ICT industry might see fertile ground for collaboration projects and helping the industry to move forward. So I might just move through some of those areas. First one is the electrification of everything. So this is commonly talked about in the industry, and consensus generally is a lot of it is focused on the conversion of hot water, process heating and cooking load from gas to electricity. A significant increase in the amount of electricity flowing through the veins of our system and being charged through the retailers and generated through a whole range of decentralized systems. But in truth, it's much more than just the gas conversion. There is electrification happening in all of consumers' daily lives. Some of the growing examples, you know, Tom, you mentioned utes in the chat at the very beginning of this. You know, the future of tradie utes are as enormous mobile batteries on our system. And imagine all of a sudden you're dealing with big demand and big charging loads that are mobile on a system that has been static for such a long time. It becomes a really interesting challenge. And they are bringing new electrification to all sorts of things that they do in the workplace, including drones for lifting and inspection, and a whole range of new tools. In the leisure space, yes, they have electric caravans now that can assist with towing and can self-manoeuvre. They're in prototype, but there's 900,000 caravans in Australia, and look forward 20 years and you wonder how many of them will be in circulation, connecting and disconnecting, charging and discharging in all sorts of caravan parks and camping spaces and homes and businesses around Australia, as well as, you know, an enormous plethora of watercraft that are all becoming electrified. We look at mobile micro-mobility, whether it's in the air or whether it's on the ground. There is increasing amounts of that forecast to come onto the network, again, all mobile, again, creating lots of challenges. And then there is the relentless electrification of appliances in our home. You know, every year we have a new must-have appliance like a robot vacuum, an air fryer, or now the latest one is a benchtop ice maker. These things just are set to keep increasing the amount of electricity that we need and the challenges of supplying that at peak times through the day. The implications for the energy industry are that customers are going to expect to plug and play. You know, I want to go and buy another thing and plug it in, and I just expect it's going to work. The people who sell electricity to these people are going to be keen to make sure they capture all of that power, no matter when it's used and where it's used. And the networks are going to need to understand when it's likely to be used and how it's going to be used, because they have to support the system that does that. So customers expect that just to happen. So this is some big challenges for the industry and great opportunities for the ICT sector to bring their expertise in managing and aggregating data, balancing information. You know, there's some real-time identification of load and sense making about whether, as load comes on the network, is it permanent, is it transient, how long is it likely to be there, who does it belong to, reconfiguring networks at speed so that they can keep quality and reliability going. You know, there's just so much complexity there, and this is a great opportunity for collaboration moving forward. I've already talked about orchestrating all of this distributed energy resource. In different arenas, it's called customer energy resource because a lot of it is customer owned, EVs, batteries, solar, and the increasingly new electric appliances I just talked about there. But I think the size and the impact is definitely going to grow. You know, there's a lot of this going to be connected to the network in the next 20 years. But I wonder whether the challenge of orchestration is changing as well, and whether it might be becoming more nuanced and right into the scope of the ICT industry. And let me just explain. So this week, our bills went up, our electricity bills supposedly went up 25%, and we'll see that impact flow on in the next 6 months. It will really start to hit us when those quarterly or monthly or 2 monthly bills start to turn up and we realise the full extent of that. At the same time, if you've got solar, you know, you used to get 15, 20 cents per kilowatt hour or per unit for everything you sent to the network, and now it's more like 5 cents. And that hurts, and that's a serious touch point for consumers. And they start to think about, well, why am I selling it for 5 cents a unit and buying it back for 30 cents a unit? Which brings their thoughts to, I need to get a battery. And of course, 3 million households have had a lot of success buying solar, buying their own energy plant. And so it's not a big step for them to start looking at the economics of buying a battery. And all of the things that are happening with electricity pricing and feed-in tariffs make the decision a lot closer to making sense to them. And so we need in the orchestration space to get good, clear signals, to how consumers should use all of that customer energy resource. The strong signal I just talked about, which is storing more of your own self-generated stuff, I think is going to become increasingly apparent. I don't even think we'll have to sell that. I think people will naturally buy batteries and trend towards jamming as much of it into their battery as they can from the rooftop solar. But then with a little bit of work, we should be able to convince them, if they've got excess capacity, to pump that back into the networks during peak time. And that might lead some of the populace into search how they can make more out of their battery. And that might be buying cheap electricity at 2 or 3 o'clock in the morning, or buying other people's solar if they've got spare space on their battery in the middle of the day. So the point is, I think, we used to worry how we would get the customers to take part in this orchestration, because orchestration is a really challenging thing. But I think what you'll see is, if I can use the word, tribes or groups appearing that either take advantage of exploring all the price signals that could exist, or some of the price signals, or one of the price signal, but there will be different groups or teams that will act in different ways, and optimizing all of these different groups so that you can orchestrate what's flowing into the network from the distributed generation and storage, and what's flowing out becomes the challenge. Customers will want to use their equipment because they paid for it. They'll want to export to make as much money as they can, and they'll want to generate as much as they can, and probably not be really happy when they're being curtailed because of too much impact on the network. But, this is a challenge. So they'll be looking to work how they move forward. Industry is going to have to plan, and they can probably benefit from having the ICT sector help them. There's a lot of pattern insights here and behavioural patterns, and I've seen that in a lot of the work we're doing now, and leveraging those patterns becomes a real opportunity. Real-time optimization can almost be done. Optimization at the moment often happens at macro level, but as more data becomes available, we can almost optimize neighborhood by neighborhood. So that becomes interesting. Overseas, you see retailers in the food industry optimizing inventory by dynamic pricing that moves by the minute based on what's going off the shelves and what's going through the cash registers. Well, I think the same thing probably applies for what's happening on the networks, and being able to offer strong signals that attract an early subscription from customers to either support the network or take energy away from the network if it needs to. Dynamic pricing becomes a real opportunity, and this is something that industry is going to have to deal with. It's a sweet spot for some of the people in this sector. Issue identification and identifying opportunities that come through. There is, in this orchestration space, I see some big data opportunities, and I see lots of capability in the Australian industry to really drive this forward. Of course, cybersecurity has to be there. And after 2022, which was just a breathtaking time for consumers in the cyber world in Australia, the energy industry talks about how trust is critical if we're going to enlist them to help us to move forward. But meeting expectations is how you build trust. And perhaps from a cyber point of view, a lot of other organisations outside of electricity industry haven't done so well in meeting expectations. And part of meeting those expectations is understanding the assumptions that underlie those expectations. It requires really understanding what customers want out of your system. And often, and I mean often, corporates don't go down to that deeper level, and they substitute their own assumptions about what customers want, and things can go wrong. So last year a lot of corporates might have been thinking that customers were saying, or consumers were saying, protect my data, and the underlying assumptions they thought that meant is know the attack surface, understand how you're going to respond when you're under pressure, get the best systems, get the best people, set up the best security operations system, centers and encryption, and make sure you're prepared, ready, and responsive when things go wrong. But we found out last year through social media and the media itself that what the customers were saying was not protect my data, protect my identity. I don't care about my data. A lot of people have got my email and my phone number and my name, and some people have got my address, and that data's been breached so many times in the past. But my passport number and my driver's license number, you know, I really want that encrypted. I don't want that going anywhere. That's what's important to me, because that's how people are going to take money off me. So why don't you encrypt it or tokenize it, or better still, air gap it away from the systems? And why do you keep all the data in one place? Why do you create this golden egg where everyone can come and take all of your data in one place? And why do you keep my data for 15 years? And, you know, when the state actors turn up and start attacking one customer in Australia, they've declared war, which means it's not just one company in Australia. There's lots of companies in Australia that are under attack. And so maybe you should be going and doubling the number of guards you've got at the front gate, rather than, you know, just thinking about what plans you've got in place, because, you know, this is my identity. What it means for the electricity industry specifically is customers' expectations have grown, and they've learned from the past. They expect that the industry will take the time to understand what it means to them, and that the industry recognises there are a lot more at stake. You know, and hackers get into networks and start playing around with voltages. That volatility can fry your fridge or your TV or create havoc in your home. So it's much more than just your identity. So, you know, this is writ large for the energy industry. And luckily, the ICT sector brings enormous and growing capacity in this space. I know the universities are pumping out lots of graduates in this space and are teaching, you know, really good skills into this space. And we've got to get those skills into the energy sector. Not only just as business as usual, but the ICT sector can help with ongoing development improvements, bring additional resources in as needed, and assist with planning. So there's a long story to be talked about here about collaboration and where we can go together to really plan for the future. And the last one I would just quickly want to talk about, and for me this is important, is machine learning, artificial intelligence, and large language models. This is the stuff that brings the real unimaginable efficiencies. This is the stuff that really can make low cost energy for people, things that we never thought could be achieved. And it's happening every day. In the university, I see it in sectors like health and retail, transport, communication, are delivering step changes, billion-dollar changes to revenue and improvements in customer services. And there is enormous opportunity for this to happen in the electricity industry. And it's fair to say that, you know, much of this is still to be done. Fertile ground, I've talked about dynamic pricing, contextual price signalling, you know, putting signals in front of people when in the area that they're in, with the message that you wanted, the time that you want them to get it. Outside of the energy industry, people are doing great things with bots that deliver great customer service and really, really useful information to customers in a timely manner, rather than staying in line and wanting to talk to a human. And, you know, bots are being used by a large and importantly a growing sector of the community, because that's what people want to use. They want to access the information quickly. This is a great opportunity. Faster troubleshooting and response, you know, data and information and artificial intelligence can drive us straight to a point where there is a problem on an electricity network. At the same time, it can be dispatching the right assets who can fix that, and the right equipment required to fix it, and the right spare parts that are needed, or to go on a search for the right spare parts. What that means for customers is they get their power back on quicker. Self-service for people like developers who want to work out where they're going to put their next big development, or customers who want to get connections, disconnections, a running tally on their bill from the retailers, whatever it might be. This is where this sort of topic becomes important. In Queensland, the networks up here are doing great jobs identifying faults on the network in consumer homes using data, and that's something that should spread further, and the fault landscape could expand as well. There is load on the network that right now is switched on and off, but I think there's opportunities for much more nuance in the way that load is switched, and there is certainly underlying patterns. You know, I think there's 700,000 hot water systems that get turned off in Queensland every night. If you look at the deep data, you can see houses with school children during term have patterns in the way they use their hot water. And that talks to absolute efficiencies in the way you can do that switching. And then we can look at micromanagement of the network feeder by feeder, neighbourhood by neighbourhood. So, you know, this is about better efficiencies, better pricing for customers, better service levels and better safety. And I think the whole machine learning and artificial intelligence is very much a sweet spot for the industry. So they're just 4 examples of where I think the future lies in this opportunity for collaboration. I'm happy to talk more about it when the time's right. Thanks.
Thanks very much, Neil. And I think we've seen with each of the speakers, we've gone from the sort of the economic and infrastructure analysis that Michael has presented with different pathways that are possible. As he said, the work that they've done isn't recommending one pathway, but it's mapping out different ways that might be possible. And then John has told us more about the complexity and the integration at the systems level. And now Neil talked us a lot more about the sort of the consumer and end engagement level for the community. And you can see everybody is focusing on the same core issues, but there are many different ways to see it. So with that, I want to remind you that this is meant to be a discussion. So I really do want all of you to participate. Feel free to put your questions in the chat, but also use the Zoom tool to raise your hand, and I'll invite you. And while I'm waiting for people to come forward and ask some questions, I want to go back to Michael and just ask Michael, if you want to identify out of the work that you're doing and your perspective, just 1 or 2 opportunities where you see the ICT community in Australia could not only make a big difference to this transition, but achieve something that would offer those companies and perhaps Australia a global competitive advantage.
Thanks, Jordan. Whether it's directly coming out of the work that the Net Zero Australia project or not, I'm not entirely sure. I mean, I've worked in this area for quite a while now, so where good ideas come from, I can't always remember. But I'll sometimes claim them my own mistakenly. But there are 2 things that really come to mind. There's just an enormous amount of interplay between ICT and energy infrastructure. But I'll give one, and I think it very much ties in with Neil's thinking and John's as well, and it probably duplicates a fair bit of what they said, which is around how we coordinate distributed energy resources and distribution networks. That's a whole area where John was mentioning and Neil was mentioning, we don't have a lot of understanding of actual instantaneous operational information and how to optimize and coordinate that dance. I think that's a huge opportunity. It will reduce greenhouse gas emissions if you get it right, but I think it will unlock very significant economic benefits for people, particularly around through better coordination of physical infrastructure. You therefore need less physical infrastructure to achieve the same outcome. And your community is very mindful of how better optimization of resources means that the expensive stuff, big bits of kit, you need less of it, and that's very important for consumers. The second one is perhaps is much less obvious and perhaps a bit more sort of disruptive, but also I think really important, which is I just don't understand why buying electricity, or gas for that matter, but particularly electricity, is so jolly complicated. And I don't understand, with all of these smart meters, certainly we have in Victoria, and all these online offerings of this, that and the other, why there isn't some kind of disinterested intermediary who helps individual households in a completely automated sense minimize their energy costs. Now, there's a whole forest of complexity underneath that statement, but that would be a challenge that I'd throw out to the IT sector, which is, my 86-year-old father is not interested in understanding what a power factor is. He's not interested in knowing how many kilowatts of solar he should or shouldn't have on his roof. He just wants to know, how do I make my electricity bill low and keep it low with minimum complexity?
Yep, I think they're 2 very good options. And of course, that highlights in both cases that the introduction of more software capability alongside the infrastructure creates more agility. So like you said, reduces the need for constant expensive change of hardware if we can leverage the ability to use software to make the hardware more efficient and more adaptable. So John, I would ask you the same question.
In that case, I'd need to try really hard to remember what the question
so the question
was.
is one or two opportunities that you can see where the ICT sector can get involved in helping this electricity transition to happen, and as a result, not only make a significant contribution to transition, but also perhaps generate a globally competitive advantage, whether it be for the companies who come up with the solutions or for the country through its economic positioning of energy.
Okay, now I'm going to start by saying my answer is going to be probably deeply boring because I covered this a little bit in my talk anyway, and exactly as the previous answer, really that efficiency in our resource usage. So the amount of expensive kit that we need to replace, and it's not just the cost of that kit, but actually if you're going to replace transmission distribution infrastructure, there's a lot of engineering work and construction involved in that. So the better utilization of that is the major challenge that I see there with the major benefit. And that really comes down to actually the better understanding of what the operational limits of that infrastructure are and where the flexibility sits in our system. So the extent that you can work with industries, businesses, consumers, in not requiring them to know everything about the electricity system, but to make it easy for the devices that they have and the way that they use energy to be flexible when it can be, to minimize the, well, to allow that coordination between your generation, your infrastructure utilization, and ultimately the use of that energy. Coordinating those, aligning those is where that efficiency comes from, and making that easy for businesses, industries, consumers to achieve is that opportunity. That's the number one.
Sure, thank you. And Neil, since you already addressed a lot of this in your presentation, and we've got some other people who want to ask questions, I hope you'll forgive me, but I'm going to go straight to the first question from Jeremy Harkins at Green Shield.
Oh, hi. Thanks for that. Look, it's not so much a question, it's more just a comment and a bit of a response to Michael Breer. So when I think about Michael's grandfather, I think I see one of the key issues kind of here. It's often about the end user. And most people don't care, to put it simply. Like we're adding complexity, we're adding all these solutions. And most people just want to plug it in, get on with life, and do things how, when I think about, again, the grandfathers of the world, how they did 50 years ago. And that's what we're not really linking. We're not linking this base human activity and this ability to affect, or apathy, to put it simply, with our complex ICT solutions. And when I think about the ICT solutions that can, or how ICT can help these problems, I guess I see it's in reducing complexity. And that's what ICT is not doing. We're adding more software, we're adding more systems, we're adding more choices, and we're actually not really describing through these great technologies essentially how to quickly explain something to someone all the way down at the base level, even a homeless guy. So anyway, that was kind of my comment. Thanks very much.
No, I think that's a good observation.
Jeremy, I agree with you. I think that level of apathy and the need to automate, almost make a lot of the stuff that we need ubiquitous happening in the background is important. I just would hate for us to lose sight of that trust bit I talked about in cybersecurity, because it only works when we build trust in those systems. The moment those systems let them down and they abandon those systems, and they're back to step one, where they're facing the complexity full on.
That's right. And that's where you see people just go, throw it all away. Kind of like, just like the woman who wasn't allowed to withdraw cash from an ANZ bank the other day. Apparently people are now getting rid of their debit cards because they actually don't trust the system anymore. So it's actually specifically about building trust in the system. And that's, I think, a key issue that needs to be included in all these conversations. Thanks.
Right. Well, I'd like to move on then. Jared Basson has a question.
Hi, John. Thanks. Jared Basson from Hatch. I've got a question probably directed to John more than anyone else. And we talked about the exported, I guess in the first session with Michael, we spoke about the exported carbon in coal and in iron ore when it gets converted to steel and so on. The question is, how do we get, what mechanism exists for Australia to get either credit or incentives for technologies that reduce the carbon intensity of the materials that we export and get used overseas? So, for example, if we're developing technologies for green steel, for reduction in carbon in blast furnaces and so on, how do we bring that, or do we get credit or recognition or some other incentives for achieving those outcomes? Because frankly, as the graphs that Michael presented showing, the bulk of the carbon from Australia is actually what we export, not what we consume domestically.
Oh, I think that might be a Michael question.
Sure.
Michael, are you okay to take that? Or?
What I could, but I'm keen to hear diversity of thoughts on these things. I don't want to dominate the conversation. The exported, I mean, looking at the exported carbon in particular, Jared, yeah?
Yes, yes. So the technologies that will cause a reduction in the use of the materials that we export.
So it's a good question. I mean, the most. I mean, at the end of the day, you put a chunk of coal on a ship and send it to Japan. It's high quality black coal. It's almost entirely carbon, and so no amount of smart ICT is going to turn that into anything else, and ultimately not into CO2 if it's used. So I think it's a more general thing around how much we can disembody how we achieve, what we want to achieve as a global civilization through better use of resources. That's just a sort of I apologize if that's a motherhood statement, it's just a generality, but I do think that sort of if we view this whole challenge as a kind of real-time optimization problem, that for which, of course, advanced ICT is enabling, that just strikes me as the way to do it. But I mean, we can't completely deny the physical reality of many of these heavy industrial processes. And Neil, for example, has been working for a long time in distributed energy systems and network infrastructure. And a lot of people who come to this sector come to this problem from a non-electrical engineering background. I'm not an electrical engineer, but people who come to this problem as non-electrical engineers don't have a sort of a bottom-up appreciation of the fact that transformers have physical capacities and limits, and lines have limits, and there's power factors and all these physical things you need to think about before you start doing clever things like peer-to-peer trading and this and that and the other. So you can't forget the physical reality of these heavy industries and the carbon in coal, but you can reduce the material use enormously through this grand optimization challenge. That's sort of the way I'd look at it.
Yeah, I guess it was, just to take the example one step further, I guess what can we do in Australia to incentivize people to find solutions to either, say, for example, with coal, you can do carbon capture and storage. There are carbon capture and storage technologies that could be developed, for example. There could be alternatives to using carbon in blast furnaces to produce steel, alternative steel making methods, for example. So how do we encourage and incentivize, just to pick that as an example, how do we encourage and incentivize in Australia people to develop technologies, ICT or otherwise, to achieve those outcomes? Because there will definitely be things that we can do, but a lot of our focus is on the decarbonisation of Australia. It seems to me that incentives generally, in the discussion generally, is about incentivising decarbonisation of Australia, which of course is logical. But given that we're in that strange position where most of our carbon is actually in export, is actually a lot of it is exported. How do we shift that and also encourage Australia to become a developer of technologies that
Sure.
Maybe
So at the end of the day, people buy stuff from Australian companies. So the way to get them to not buy coal and to buy something clean is to shift the consumer sentiment and the customer sentiment. And I'm not personally not a supporter of the supplier of the fossil fuel dictating to the customer what they do and don't want. And that because it'll be doomed to failure, that kind of approach, because, for example, people will get what they want from elsewhere if we can't convince them that what we've got is the best stuff for them. So that transition challenge, I mean, of course, as we well know in all our industries, suppliers can educate customers and help them look at different options and so on. So I think Australia has a very important role to encourage the customers of our fossil fuels to look at other things and to be presented with interesting and attractive options. So that's something that Australia can do. And then there's a bunch of people inside Australia helping formulate those offerings to other people is obviously a national priority, and it should be a real priority of all of us, particularly our governments, to support Australian companies to come up with options that are commercially attractive to other countries. But it's a very difficult problem, and it's a grand innovation challenge. I'll give you a couple of things that are pretty arresting. I think about 3 billion people on the planet today per person use about as much energy as Australia, Europe, and the United States did in the mid-19th century. So trying to sell someone something which is much more expensive than fossil fuels right now, when they're, let's say, 150 years or so behind us in terms of energy consumption, is a difficult thing to do. But if we make green energy much cheaper, then people will buy it, particularly high income countries like Japan, Korea, and elsewhere in the first instance. So and now, I mean, I don't want to sound too cravenly self-interested. I think the kinds of, that's $7 to $9 trillion of investment, I think involves at least an order of magnitude growth in investment in energy RD&D in Australia. So that's an interesting number for people like us.
So when I didn't answer the question, what I didn't want to do is go down the route of a motherhood statement around international agreements and going down the route of Scope 3 being not our problem and all of those sorts of things. Certainly internationally, we want to achieve that, but the mechanisms, it's a little tricky to go too much into that. For the purposes of this discussion, though, I think the ICT angle here, where there is an opportunity, is the provenance of our raw materials, our resources. So if you're buying Australian coal and consumers can actually, or manufacturers can know the provenance of that, if that gets more important as we go to things like hydrogen, where you want to know, was that hydrogen produced through steam methane reforming, or was that produced electrolysis or PEMS or whatever it is with renewable energy? Was that natural hydrogen that someone extracted somewhere around Australia? Whatever that provenance is, being able to have confidence in that supply chain and where those materials came from, that is something that is an ICT challenge, and it's something that would actually help with this issue.
Excellent. Well, so I do know that Tim has been very patient with his hand up. Now, Tim, did you have something in addition to the Scope 3 discussion that you've been putting in the chat?
Oh, sorry. The Scope 3 thing it's just a mind stuff up. And I know it's an issue, but how we get anyone to agree on it is just not wasting it. I'm John and Neil in particular on the data stuff. So I'm doing a lot of stuff on the data, driving things, heavily involved in the AMC's Power of Choice review, and hosting one of these sessions or moderating one of these sessions later. I just think if we think about the system as an energy transformation, and the system has flipped or will pivot on DNSP, so customers are at the top of the pile and are driving everything, and fast forward and look back at what data we need for the consumers to be able to do things automatically. And it's not worried about my mother or someone else's grandfather or anything else. These things, need to get to a point that they're automated, that air conditioners will automatically time shift if it knows and understands that the house has a thermal load capacity. And I'm particularly challenged in all this at the moment that our DNSP's tariffs seem to be trapped in a system where they are high friction and therefore are ordered around maintaining the current the current status quo of retailers setting the pace all the time. I'm just wondering how we take data and what data do we need to get consumers moving?
So there's a couple of parts of that from where I sit. I think, first of all, getting the data is something you need to think about. And, there's a lot of talk about smart meters, but through some of the work we're doing, it's becoming more and more apparent just how much data is available in homes today and is likely to become available moving forward. It might not be utility grade or quality data, but one of the things we saw coming out of Europe is sometimes you don't need completely high quality sets of data. You can mix high quality with low quality and get to a decision point that's almost efficient. And in time, you migrate towards all high quality data. So the first point is there is data there and there's more data coming, and so that's got to be a good starting point for how we start to solve this. But more than that is then demonstrating that data can add value to the system. And then the third part that's, as you said, really problematic is finding courageous retailers who will put together tariffs that can leverage that data for the benefit of the systems and the benefit of the customer, and probably eke out better margins for them. But to date, we really haven't seen the competition that's driven those retailers to do that. The big ones come in and they just have a model that they run, and there's a cost-driven model. And the smaller ones come in and they all seek out a little niche, but I just don't think.
The big challenge that is the underlying DNSP tariffs, isn't it, Neil? Like the big,
definitely.
The big four generators are locked us in on a tariff structure that is built around the generation to transmission to distribution, and everything was coupled. Distribution is now uncoupled, but we are still seeing those tariffs locked in such a way that it preserves the market power of those big gentailers. They don't have to pass through the DNSP tariff, so therefore they can pick the low-hanging fruit and do the services. But a new retailer, innovative or not, has no choice but to pass through the tariff because they don't have a book. They can't manipulate it. They can't find anything.
I agree.
And so the really interesting thing is because of the financially responsible market participant, also known as a retailer, they've got control over the data. They're not letting anyone have it. They're trying to stop DNSP's access to it. But the AMC review is going to turn that on its head. The latest material from the AMC says real-time data is going to be available to consumers. They'll be able to pass it to their DNSP. We'll be able to see dynamic operating envelopes. The question for me is whether it will happen fast enough and quick enough, and how much opposition we will see from incumbents.
It's a double-edged sword, isn't it? I totally agree with that whole network pricing. There's been talk at times of postage stamp pricing, which goes against the thought that everyone in a state should all pay the same price for electricity. If we go to postage stamp pricing, there's almost certainly going to be some streets and suburbs where the network charges should naturally be much, much higher than others. And that's a challenge for us as a society. That's one side of it. The other side of it is we've been able to hide for a long time behind the complexity of this issue and the fact that we don't have data, and we're getting data now. So we can actually, we should be able to actually get much more responsive tariffs that are location and time of use responsive, and there should be benefits.
Yeah, things like the Ausgrid Project D stuff, like fantastic. There was something you said there I was going to jump on.
The postage stamp pricing.
Yeah, so postage stamp tends to be more universal. Like it's not. We do need something that actually separates that and gets us down to a frictionless tariff. So we need some sort of subscription that is equitable, I think, as well. So because ideally, the idea that consumers should buy a battery is being foisted on them by people who'd like to control the battery, and then money from the battery, be a VPP, do whatever, and get the consumer to invest the cash. Where really it's 10 times the cost of doing it at a community battery level if we had no friction between the consumer's household and the battery up the street, of which there shouldn't be. So but of course, generators, retailers, etc. say, hang on a minute, I think a battery's a generator, or I think it's my retail bank. I want to control that, and the DNSP should have no value in it. So what really worries me a lot of this is we're not getting people with the ICT skills into the energy system, or helping our regulators or helping our rule makers like the AEMC understand just how data and how technology can work, because with the greatest respect, they're all economists, most of them, trying to look at market solutions and services, where we're now talking about technology solutions, which don't necessarily rely down on a market, but rather behavioural economics or people's behaviour about how to achieve things.
The other thing is there's a big risk management component here, and DNSPs are big enough to be able to take some exposure, whereas a small retailer has a lot of challenge trying to manage that sort of risk.
Why should a small retailer? Every house in the street is connected to the DNSP, connected to the community battery. There could be 3 retailers that are servicing most of them, and then 2 or 3 retailers that are serving 1 or 2. To me, it makes little sense that community batteries are starting to be seen as assets that are dropped in by a retailer or a generator to say, oh, I'm dropping stuff in the network, rather than saying, how does the community, which is the biggest generator in the area, not get to service that storage mix? But
I think a challenge though for small retailers is that as you make these things more optimized and more automated, they're in a difficult spot because they haven't got the natural hedge of being both a generator and a retailer. So as margins fall, they're going to cop it much more than the big guys. So I think I'm not that bullish personally on having large numbers of retailers providing niche services to different customers, because I think that competition and automation will eat its own lunch. I think the ICT offering, everybody, they'll all cut each other's lunch, and then they'll all go out of business. And I think that's a common story with small retailers. But I think the ICT sector coming in as a kind of independent intermediary between customers and retailers, and helping retailers decide what is their best offering is a very important thing, because to offer independently of retailers. I don't know how we do that. I mean, there's Energy Compare in Victoria and elsewhere, but I don't think they're by any means as smooth as they should be.
Michael, interesting question. Who do you think?
Sorry, Tim, I'm just very conscious of time. We're just about to run out of time, so I apologise to have to cut you off. I just like to acknowledge very quickly, there have been some very interesting comments going on in the chat. Akhtar Kalam and Jeremy Harkins have had an interesting debate about the balance of data and human-centric, which I think has been touched on, particularly in the way that Neil gave his presentation, but by everybody who's spoken today. And Paul Cooper's made one of the suggestions about coming up with green-powered data centers in Australia, in his case, particularly for training AI foundation models. That's, I think, one of those interesting ideas of something that we probably could do and could be very practical and could address both globally competitive outputs as well as addressing our energy issues domestically. So a lot of interesting topics, and I want to thank everybody. I would like everybody today to join me in thanking our panelists for spending their time with us. And I'd like to thank all of you for staying with us throughout this time. And in particular, I'd like to thank the session partners for this session. So the Melbourne Energy Institute at the University of Melbourne, and also the Department of Electrical and Electronic Engineering at the University of Melbourne, who have helped us present this session today. And I'd just like to remind you all that we are only the first of a continuing series. So the next session is going to be coming in 2 or 3 weeks. At the moment, it's scheduled to be the Future Grid session, which is going to start looking more deeply at these specific topics around the grid. Today, we've taken this very broad view. Each of the sessions over the next 5 sessions are going to drill down into areas around the future grid and the intelligent use of systems and the IoT elements and other things. So I encourage you to go to the website to register for the sessions as the registrations open, and we really do look forward to having you all with us in the future. So again, thank you all very much for being with us today, and we'll set you free.
Thanks, Jordan.